Okay, so for question 2.31, I think it's just going to be a verbal answer. There's no computations involved here. So the temperature of the interior of the sun is, well, it's super high, 15 to 10 to the power 6 Kelvin. Um, I guess, yeah, the question they're asking is to explain why fusion does occur in stars despite the above mentioned difficulty. So the difficulty they're mentioning is about nuclei not having enough kinetic energy to overcome the electrostatic repulsion between nuclei and approach each other so closely to undergo fusion. And that would make sense if you're looking at it through classical mechanics. Although molecules, none of the molecules have enough kinetic energy to overcome these electrostatic repulsions, the repulsion barriers. According to classical mechanics, we have seen when we study tunneling that quantum mechanics does allow nuclei to tunnel through the barriers. And we also saw how tunneling can play an important role in certain chemical reactions, enzymatic catalysis, and all that, right? So although classical mechanics doesn't really allow for this, quantum mechanics does, tunneling does. So there is a huge probability for nuclei to come close enough to uh, overcome those barriers to undergo fusion, and that is allowed by tunneling.